Hello there once again. Welcome back to our Exam 4 review series. This time we'll be doing problem 5b, in which we are asked to solve this system of equations. The first thing we should do in this system of equations is have a look at equation number 1. They tell us that x equals negative 5y plus 4z plus 1. Since they've given us an expression for x, the best thing to do would be to replace x here in equation 2 and here in equation 3. Let's start with equation 2. So in this position where we have x, let's replace that with a parentheses. We'll say minus 2y plus 3z equals 1. And we're going to place this expression, negative 5y plus 4z plus 1, into the parentheses. Now, let's combine any like terms that we see. Negative 5y and negative 2y, if we add them together, make negative 7y. 4z and 3z together make 7z. We still have plus 1 by itself equals 1. Now we'll subtract 1 from both sides. Minus 1 here and minus 1 here. We'll cancel both on the left and the right. And we'll have negative 7y plus 7z equals 0. Now we'll move on to equation 3. So in this position, next to the 2, we'll place a parentheses. Plus 3y minus z equals 2. And in that parentheses, once again, we'll place negative 5y plus 4z plus 1. And we'll multiply the 2 to each of these three terms. So 2 times negative 5y makes negative 10y. 2 times 4z makes 8z. 2 times positive 1 makes 2, plus 3y minus z equals 2. Once again, we combine any like terms that we see. We have minus 10y plus 3y makes negative 7y. 8z minus z makes plus 7z. We have the number 2 on the left also, and a 2 on the right. Now we can subtract 2 from both sides. The 2's will cancel out on the left and the right, and give us negative 7y plus 7z equals 0. So look what's happened here. On the left, we have the same equation as we do over here on the right. Negative 7y plus 7z equals 0. So if you have the same equation both times you simplify, that means the type of system you have is a dependent system. Now, a dependent system has infinitely many solutions. So if you have infinitely many solutions, z can be anything. So the only letters we can solve for are just x and y. We're going to leave z as a letter and then solve for x and y. To do that, we're going to use this equation, negative 7y plus 7z equals 0, that we just wrote. And after that, once we know what y is, we can use equation number 1 here to solve for x. Let's try that now. So, starting from negative 7y plus 7z equals 0, we are going to try to solve for y. So let's move the 7z over to the right. We'll have negative 7y equals negative 7z. Then, if we're going for y, we can divide by negative 7. So we have y equals z. So now, once we know this, we can move to our other equation here on the right. We're going to let z stay as a letter, and also let y equal z because that's what we just found. So we'll say x equals negative 5, change the y to a z, plus 4z plus 1. If we combine our like terms, negative 5z and 4z make negative z plus 1. And that's as far as we can go with this. We can't make z into a number because we have infinitely many solutions. So our final solution can be written in these triangular brackets, and you always write your solution in the order x first, y second, z third. Our x was negative z plus 1, comma, our y, which was actually z, and of course z stays z because it has infinitely many solutions. Thank you all for watching. We'll see you again soon.